Today we're going to revise a topic that is the stress strain diagrams, because I already told that this strength of material is totally based on the stress and strength. Okay, so you have to know more about the stress diagram. So for that, today I'm going to share with you a small video which is full describe or detailed describe about the stress strain diagram. So for that, first you have to view very carefully this video, and after this I will ask you some question regarding this. Okay, I will ask you some question regarding this. Okay, so today I'm going to share the stress strain diagram for the ductile material. So you must have go to that, and whatever your doubts, just ask after finishing the video. Okay, let's start.
इस चैनल पे हम लोग इंजीनियरिंग मैकेनिक्स पढ़ रहे हैं और इंजीनियरिंग मैकेनिक्स में जो टॉपिक चल रहा है ये सिंपल स्ट्रेस एंड स्ट्रेन का टॉपिक चल रहा है। तो इस टॉपिक में कल मैंने आप लोगों को बताया था कि व्हाट इज स्ट्रेस, व्हाट आर द वेरियस टाइप्स ऑफ स्ट्रेस, व्हाट इज स्ट्रेन एंड टाइप्स ऑफ स्ट्रेन। इसको कल हम लोगों ने डिस्कस किया था। तो सिंपल स्ट्रेस स्ट्रेन को ही आगे बढ़ा रहे हैं। आज जो टॉपिक है ये है स्ट्रेस स्ट्रेन डायग्राम, स्ट्रेस स्ट्रेन डायग्राम फॉर डक्ट।
So, okay, students, there is any doubt? Students, there is any doubt? So, if there is any doubt, then ask your question. Okay, student, any doubt? If there is any doubt, then you can ask your question. So, otherwise, I will share one more video which is belongs to a stress state diagram for the concrete structure, means for the concrete material. So you can see what is the going on. Previous video is related to the uh, stress strain diagram for the ductile material. Okay, for the ductile material. So now this video is belongs to the stress strain curve for a concrete material. Okay, how concrete material behave in stress strain diagram during the during the load application. So let's start.
Of the concrete stress versus strain curve. So in this lecture we are going to discuss the curve between the stress and strain for the concrete material. So if I take these two axes, the y-axis shows the compressor stress for the concrete material, compressor stress in the unit of KSI or maybe PSI, pound per square inch, or the kilopound per square inch, and the x-axis shows the strain, which has no unit, or we can represent by inches over inches, but strain is a unitless quantity. So if I show the y-axis with the compressor stress and the x-axis with the strain, then we have a plot between these two quantities for the concrete. So for the concrete, to draw the curve between the stress and strain, we have to perform some test on the cylinder so we can get the curve. So actually we make a cylinder. This is a concrete cylinder with a diameter of 6. Place this concrete in the universal testing machine, which is called the UTM, universal testing machine, and we perform the compressor test on this cylinder. So by performing this test, we get a curve between the compressor stress and strain, and this curve is known as the stress versus strain curve for the concrete material. So after performing the test on this concrete, we can get the elasticity of the concrete from this test. So let's suppose we make the cylinder and we are going to perform the test on this cylinder, which is made up of the concrete. This cylinder is made up of the concrete. So By starting the test, the curve will be straight, will be linear for some time. It means the stress and strain have the linear relation at the start, and then after increasing the load on the cylinder, it will be deviating from the linear position and will be showing the nonlinearity, and then increasing, and then reaching to the top of the load, and then it will decreasing again, and it will show breakage here. And this point is called as the rupture of the concrete. It means now the concrete has been ruptured in parts and it cannot take any more load. So such type of curve we always obtain from the concrete, either made from the normal concrete or from the high performance concrete. So this point at which it cannot take any further load is called the rupture point for concrete, and its strain is usually represented as ECU. This is the rupture strain for this concrete, and this will be called as the
Grammarly is by your side, especially when you have a mountain of work and you're short on.
ultimate strain for this concrete, which we tested in the universal testing machine. While the vertical axis we have the ultimate compressive strength for this concrete material. So we have on the y-axis we have compressive strength, and on the x-axis we have the ultimate strength for this concrete material. So this is for the one material. Let's suppose we have a higher strength. We now have a higher strength concrete. This was the normal strength. Let's suppose now we have a high strength concrete. So it will show more strength, like in this way. But now the point of rupture will be less. Point of rupture will be reached quickly as before, because now we have higher strength. The strength of the concrete has been increased, and we have the same strain, but we have the same ultimate strain, but now the point of rupture will be less as compared to the normal strength concrete. So if we are increasing the compressive strength, if we are increasing the compressive strength for the concrete cylinder, then the rupture point or the rupture strength for the concrete is going to be decreased in a decreased way, while the ultimate strength remains the same. So mostly the rupture strength for the concrete ranges from 0.003 to 0.004, while the ultimate strength ranges in the value of 0.002. So if we are increasing the compressive strength, we are increasing the compressive strength in the other way, our rupture strength is going to be decreased. So this is the important point that we can get from these curves, from the normal strength and from the high strength concrete. The other thing is that from this linear line, we can get the elasticity, because elasticity, the stress strain relationship up to the linearity point. So we have here linear portion of the curve, so we can get the elasticity of the concrete from this linear graph just by dividing the stress over strain. Stress value here dividing by the strain value of the concrete. We can take the elasticity, or according to the ACI 8.5.1, we can easily calculate the elasticity of the concrete by using this formula: 57,000 under root FC maximum concrete strength we take from this experiment. So under root multiplying with the constant of 57,000, we can get the elasticity of the concrete. But it should be noted that this FC prime should be in the unit of PSI, pound per square inches, and the output result will also be in the unit of pound per square inches. So let's suppose if my concrete strength is, let's suppose this reaches to a value of 3000 psi, which is a normal strength concrete. So if I put this here 3000 psi multiplied with this constant, we get a value of something 3122, comma 127 psi. So dividing this value by 1000, we can convert into ksi. So it is now 3122 ksi. So this will be the elasticity for this concrete material. We can divide the compressive stress over the compressive strain. We can get the elasticity of the concrete only for the linear portion. But we can also find the elasticity by simple this formula, where we can put the compressive strength of the concrete and multiplying with the constant, we can get the elasticity of the concrete in the unit of psi. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.
Looks like you're having a hard time reading on the web. Wait, are you seriously trying to highlight on this?
Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to analyze this overhanging beam. This is an overhanging beam of total length of 10 meter, and there is a triangular load acting on one portion of the overhanging beam, and the magnitude of the maximum magnitude of the load is 3 kilonewton per meter, starting from the support and ends at the last end of the
So, okay, students, is there any question regarding concrete stress strain diagram and ductile material stress strain diagram? Okay, in comparison to ductile and concrete material, you can observe that the elongation of steel after the elasticity limit is very large, and in the concrete material there is no elongation, they can direct break out. Okay, so what happened, there is no neck formation in the concrete material, and in the ductile material there is a neck formation. After the neck formation, what happened, the material should be break at the point of where neck generation is start. Okay, but in the comparison of concrete material, what happened, the concrete material doesn't show any neck formation, and they directly go for the fracture. So if any question, students? Students, there is any question, then you can ask your question.